So here we go. This is my last attempt on this video today. It's starting to drive me crazy. Indefinite integral of a trig function, part 2. Part 2. And I'm saying on this one, this is really straightforward. We can prove this if you want to, but there's not a lot of work to do here. We can just skip to this answer if you can see it. What I'm wondering is this true? Is what we see f prime at x over f of x? If it is, then we have an ln function. So my question is, if sine of theta is the function, is cosine of theta its derivative? And I think that it is, isn't it? So here, we're going to skip right to the answer, and the answer is ln of sine theta, whoops, sorry, plus c. And that's all there is to it on that one. It makes me really happy because I know now that you're seeing the relationship much more clearly. But here on the second example, here's one that it seems to be something initially that it is not. So let's see how this second function looks really similar to the first one, and then see if we can determine how they're different and what does that mean to us. Because here I see how you just jump right to an ln function, but here that's not so true. So here is find the indefinite integral of cosine theta over square root of sine theta d theta. From here it gets a little bit weird, and because I can see how a person would see these two things and say, oh my gosh, this is just ln, I'm finished. But we're not finished, and the reason that we're not finished and the reason we can't jump to this, and we have to be really careful about doing that, is because of this piece right here, that cosine of theta is not the derivative of the square root of sine theta. So I want to be really, really careful not to assume that. So let's go to here. Here we're going to use u substitution and say let u equal sine of theta. So then du d theta will equal cosine theta. Du is equal to cosine theta d theta. I'm going to divide both sides by this because what we like to do is have a replacement value here. We like to replace this d theta value over here, so we have to figure out what that might equal. So we find this. We find that du over cosine theta is equal to d theta. And then we're going to do our u substitution here. We're going to get this. We're going to get here cosine theta over square root of u times, here's our d theta, is du over cosine theta. If you look, these things cancel out, don't they? It's here to here. Now we get this. We get the indefinite integral of 1 over square root u. I'm not even going to bother putting this du on top because it's not going to help anything. Du. Now we can start to integrate from here a little bit, can't we? So let's see if we can get back to where we just were. And we get the indefinite integral of u to the negative 1/2 power du. And here we can just integrate. So if you don't mind, I'm going to integrate before I get interrupted again. Cierra la puerta. So we can just integrate from here, can't we? And this would be u to the 1/2 over 1/2 plus c. That cleans up really nicely, right? Because we're going to resubstitute here. Going to resub here. First I'm going to bring this thing up like that, if you don't mind. And we'll get 2, right? Because this comes up as a 2. This is a square root u plus c. Go back and remember that our value of u was what? Our value of u was sine of x, sine of theta, wasn't it? Our value of u was sine theta. Just want to make sure because I want to mess this up. So finally, my final solution, I believe, is 2 times the square root of sine theta plus c is the indefinite integral. All right? Okay, I hope that was helpful. No more. I've had enough.